I'd like to take a minute and talk about excluded values and exactly what they are. Excluded values are whenever you have a zero in the denominator. As you know, we cannot divide by zero. If we divide by zero, it's undefined. So obviously, in our solving proportions, solving rational equations, we do not want to have a zero in our denominator because it's not going to give us any answers. So we want to make sure that we exclude those values that are going to give our denominator equal to zero. So kind of looking at an example right here. How do we find our excluded values? Well, we look at our denominator, which is x minus 2, and we set it equal to 0. So we're going to take x minus 2 and equal it to 0. So we need to solve for x. We're going to add 2 to both sides, which is going to give us x equals 2. So we know that x actually cannot equal 2 in this instance, because if it were to equal 2, if you look here, if we were to input 2 into x, 2 minus 2 would give us 0, which would give us an excluded, which means that 2 is an excluded value because we can't have 0 in the denominator. So 2 minus 2 gives us 0 for this denominator, which makes it undefined, which we do not want. So we can use all other numbers besides 2. Alright? And again, the more we look at examples, the more we start to understand it. So let's take a look at another example. We have 3x plus 2 over x plus 7. Well, again, are we concerned about anything going on up here? Not right now, but we are concerned about this x plus 7. We're going to set it equal to 0, and we're going to solve for x. We're just going to subtract 7 on both sides to get x equals a negative 7. So x cannot equal, and how we write that is x cannot equal negative 7, because if it did, it would make our rational equation undefined, and we don't want that. We want all of our solutions. We don't want those solutions, which is what undefined would be. So negative 7, if we were to input it right here, negative 7 plus 7 would give us that 0, which we don't want. So we know that x better not be negative 7. So that's what we put there. X cannot equal negative 7. Go into one more. It's a couple of a little more complex here. We have x squared plus 2x minus 4 over 2x plus 1. Alright, so again, we're not concerned about this up here. We're concerned about this 2x plus 1. Okay, we're going to set it equal to 0, and now we have a linear equation. Again, this should not be hard. We're going to subtract 1 to both sides to get 2x minus 1, and then we're going to divide by 2, which gives us x equals negative 1/2. So, what do we know about this negative 1/2? We know that x cannot equal negative 1/2, because if we were to plug in a negative 1/2 right here, 2 times negative 1/2 would give us negative 1. Negative 1 plus 1 gives us 0, which is not good. That's what we don't want. That's what we're looking for. So that's an excluded value right there. Now, at times we may have multiple excluded values, like in this example, with x squared minus 5x plus 6 over x plus 3, x minus 8. So in this instance, we want to set both of them equal to 0. Both of our denominators. They're both factors, but we want to set them equal to 0. So x plus 3 equals 0. It's going to be x equals negative 3, and x equals 8. Now we know that x cannot equal negative 3, and x cannot equal 8. Okay, I understand that 8 would work here, but it wouldn't work here. But again, they're both in the denominator, so we have to make sure we have both of them taken care of. So you can use every number you want to here, except for negative 3 and 8. That's essentially what excluded values are. All the numbers, you're finding the number you cannot use for this equation. All the other numbers you can use to find a solution, but your excluded values show the numbers that you cannot use to have a solution. And that is excluded values.